Well, welcome, David. I'm very pleased that you're here in Hampstead, England, and it's wonderful that we can actually meet in person.
Thank you.
I do have an agenda. There's a question I'm burning to discuss with you, and whether or not you think it has any value or not, I haven't the faintest idea. But I've been thinking a lot about the basic principles of physics recently, and trying to think about them without the fog of mathematics that normally occludes all discussion and prevents all thought on the subject. And what I'm really interested in is the question of fields, the fields of nature, which include the gravitational field, the electromagnetic field, quantum matter fields, the strong and weak nuclear fields, and, in my own hypothesis, morphic fields. The fields areas were as causes, but the thing is, as you and I and many other people have discussed, at the mechanistic revolution in the 17th century, formal and final causes were amputated from nature. We were left with just material and efficient causes, or material and moving causes.
Yeah.
But when field theory was introduced into science in the 1840s by Faraday, it was a profound revolution that in many ways went beyond mechanistic understanding. And although fields have been crammed into kind of classical science and the physics textbooks and all that kind of thing, they don't follow the rules. And what I've got this illustration that I thought I might try out on you if you're up for it.
Oh, I'm always, yes.
Yes. So this is obviously a white plate. And what I have here are a series of small bar magnets. There's one. And each one has a north and a south pole. Now, normally, when we're told about magnets, the North Pole repels other North Poles and attracts South Poles. And it sounds as if repulsion and attraction are equivalent. They repel or they attract in seemingly equivalent ways. But actually, what happens is there's a formative process going on. And what I'm going to do is just throw individual bar magnets down. And if attraction and repulsion were equal, you'd end up with a kind of random melee of magnets. That's not what happens. So, you see, although attraction, repulsion, north and like poles repels, different poles attract, sounds as if it's equivalent. In practice, attraction dominates.
Right.
And what's happening is a formative effect here. What's happening is clearly some kind of formative process. Now, let's see if we want to get both in the screen. There we go. A kind of formative process where there's a kind of causation involved here, which is not material causation because the magnetic field isn't material.
Yeah.
And it's not really energetic in the sense I have to throw them in and there's a certain amount of energy. But what's pulling them together is a force, a magnetic force. But that force is not moving energy. It's something else. It pulls them towards an end. They're attracted. But when the magnet, each of those magnets, when it attracts another magnet, loses no energy when it attracts it.
Right.
There's no expenditure of energy. And if you have a magnet on your fridge door and it's holding up a piece of paper on the fridge door against the power of gravity, it can do it for years on end. and it's not expending any energy to defy the power of gravity. And so when a magnetic field is, or a gravitational field is operating, it's not expending energy. So take the Earth's gravitational field to look at another formative field. The formative effect of gravitational fields is usually to create spheres, the moon, the sun, the Earth. But say there's a meteorite heading through empty space with a particular velocity. If it's attracted towards the Earth through the Earth's gravitational field and zooms down and hits the Earth with a big bang, the meteorite hasn't gained any, well, it's gained potential energy from the Earth's magnetic field, which gives it kinetic energy, which makes it hit the Earth. But the Earth has expended no energy whatsoever in making that happen. In fact, when the meteorite arrives on the Earth, the mass of the Earth increases a little bit, and its gravitational pull increases. So what I'm suggesting is that the gravitational field and the magnetic field are acting as formal and final causes. You know, when Aristotle said a stone falls to earth because it's seeking its proper place, and it's a final cause, actually, that seems to be the case. So I just wondered, well, and I've never seen this discussed in philosophy of science anywhere.
It's very attractive, though, isn't it? It's, it is. I mean, of course, when formal and final causes were banished from scientific language progressively in the 17th century, they had already, in a sense, been converted in the minds of many into extrinsic physical. So they were still being thought of in terms of mechanical energy, mechanical relations, push and pull. But of course, that's not what they actually are in Aristotle's thought. There, they really are a set of rational relations that are logically prior to the actions that obey them, and that are indiscernible from one another. But actually, I never thought of this before. No energy expended. Yeah, no, I mean, of course, that's always been the issue with fields, hasn't it? I mean, we don't really know what gravity is.
No, Newton was baffled by it.
Right.
And he never came up with, his own ultimate answer was in terms of the divine will, because he thought matter itself couldn't have the power to act on all other matter through the universe at a distance.
The very notion of a formal cause was something that had been so utterly altered by the early modern period in people's imagination. There was already a sort of tacit mechanism that had come into scientific or natural philosophy as early as the 14th century, and I think that by the 17th century it was a fairly established way of misreading the Aristotelian tradition. But what you're saying makes and I have to say, surprisingly kind of sense to me, because what a formal cause really is, in Aristotle's thought, is a rational relation of order that explains a possibility that doesn't seem to be inherent merely in matter and motion, right? The set of ordered relations dictated by an antecedent finality, which again isn't something that things are necessarily aiming at, but the perfectio, the complete expression of their potentials. And it's an entirely different understanding of causality than the mechanistic picture. And you might be right that maybe one of the reasons that we find fields so baffling trying to define them is because we're using a truncated causal etiological language. So you've taken me off guard here.
It's all right. I mean, it's all right for me, but I'm maybe not all right for you. Particularly,
No.
it's the thing is, you see, well, I mean, it's only recently that I've got excited by this, because I've always thought that, my whole hypothesis of formative causation with morphic fields is all about morphic fields as formative causes or formal causes. But it's only very recently that I've come to realize that all fields have that property, and that if you say, what you were saying about Aristotle, something that's not just contained in the matter or in the movement which gives a rational order, then the organization of these magnets that we just looked at, lining up, is a formal pattern that's to do with rational relations and stuff. It's nothing to do with the matter, because the matter of the iron magnets, if you demagnetize an iron magnet by heating it up, the actual amount of iron is still the same. The weight is still the same. The molecular, the atomic constitution and crystalline form is much the same. All that's happened is it's lost its magnetism. And so there is a kind of, so it's not the material cause, the iron, that's giving this effect. And it's not the way I threw them on the plate that's causing this effect, because if I'd thrown little bits of ordinary iron, if they were demagnetized, they wouldn't have lined up like that.
Right. I've been fascinated in recent years by the field. Is it Paul Davies, the fellow with the Demon in the Machine? This desire to find a way of writing information into the fundamental laws of physics, but always with the presupposition, I think, I can't speak for them, the presupposition that what they're hoping to do is to write the laws of information into physics according to the paradigm of mechanism still.
Yes.
So that in some sense you can get from information theory to the information itself. And of course, information theory concerns only bits, transmission of information.
Yes, it's very limited.
Right. It's in fact, they would call it the syntactic rather than the semantic. I wouldn't even call it that, because that's a misuse of the idea. Syntax already is an order of symbolic relations, rational. What they're really talking about would be more paratactic. It's just, and of course, I think that's the fundamental error, right? Is they realize that there is something missing from the picture that explains the propensity towards order that seems, even negentropic order, which you see everywhere in life. But they want to do it in a way that's still continuous with the 17th century scientific revolution's basic premise that everything is a mechanistic relation. And
yeah, well, I think it was doomed to failure, because I think anyway, obviously I don't represent the majority of you, but I think the key word is form, not information.
Right, yes.
I think information means puts form into something. It just mystifies the whole thing by creating another mathematical fog, because then you think information theory, quantifying bits and all that kind of thing. Whereas the plain English word form helps to explain, the form of the sun is roughly a sphere, and so is the earth, and the form of these bar magnets are sort of long, thin things, and they join up into an elongated form. All these things are plain, and our minds work in terms of recognizing forms. That's what they do. Information simply obfuscates the issue, in my opinion.
No, I haven't. You're speaking to the converted, actually. In fact, the book that I have coming out in August has, at least in part, an argument just to this effect. And I also agree that it's doomed to failure to try to understand the ordered relations of things, such as you see in a magnetic field, or arising from a magnetic field, or imposed or impressed by a magnetic field, in terms of information theory. Anything that tries to quantify it in terms of allowing it to be dissolved into relations between discrete quanta of energy or mass is not going to succeed, because the form is inherently a top-down structure.
Yes.
Even when you're talking about semantic and syntactic information in terms of information theory, one of the more nonsensical suppositions that one gets, both I think in evolutionary theory, but also in things as diverse as linguistics and physics and any other number of differing spheres of concern. The notion that somehow one can move from the quantification to this, what is clearly a qualitative relation of, or a qualitative state of ordered relations that does not emerge naturally merely from mechanistic juxtaposition or the exertion of one force on another, is never going to work. You're never going to be able to demonstrate how the one arises from the other, because it's precisely the opposite, isn't it? In fact, this is, even in information theory, this should be obvious, because, of course, information theory tells us that the greater the order at, say, the semantic or formal level, the greater the disorder at what they call the syntactic. That you can create an algorithm that repeats a limited pattern of numbers, say, in a periodic way. 1, 2, 7, 3 with repeat infinitely. But of course, that's a very impoverished. Very little information actually contained there. It can be done, but the more orderly this syntactic, or as I'd say, paratactic level is, the more confined, constrained, and impotent the level of actual, what they would call information, let's just say semantic content or formal content is. So you could never come up with an algorithm to generate Anna Karenina.
No.
It's because the causation works in the other direction. It's the semantic content which exists primarily at the level of, well, in that case, an intending intellect that's already related to the future, imposing an order on what would otherwise be simply either, well, random in one sense. I mean, it's a random sequence. At the paratactic level, the more determinate it is at the higher level, the more random it is at the lower, and in another sense, totally deterministic if it were simply mechanistic relations. So you'll never be able to get from the latter to the former. There must be, and there has to, and I never thought of applying this to fields before. And I should, of course, you talk about morphic fields, so it should be obvious, I suppose, but it seems sort of obvious, doesn't it?
Yes. Well, it wasn't obvious to me till recently that it applies to all fields, because all fields are top-down causes.
Yeah.
The gravitational field of the universe, according to Einstein, contains the entire universe and is that which through which the interrelation of all planets, galaxies, and everything is ordered through this field. But it's a top-down field. It doesn't emerge from matter. It's there to start with. It's there right from the beginning of the universe, according to Big Bang theory. According to Big Bang theory, there's a primal, M theory and superstring theory. There's a primal 10 or 11-dimensional field at the very moment of the Big Bang, which then splits up or bifurcates into the other fields of nature. But the point is that the whole thing is within a field right from the beginning. It's not that the field somehow emerges by informational processes somehow. It's there from the beginning, and the magnetic field is there from the beginning, the electromagnetic field with light and its presence in matter. And the fields that organize, the quantum matter fields that organize an electrons in an atom and atoms and molecules and things, are there from the beginning, or at least from the beginning of the molecule. So all fields, it seems to me, are top-down causes, and all of them are formative. And I mean, I'm still thinking about this, but nearly all of them work through attraction or repulsion. The strong nuclear field, for example, which is the field responsible for what are called the strong nuclear interactions, keeps the quarks together inside a proton or a neutron, and then helps shape the whole nucleus of the atom. And these are very localized fields. They only operate on the scale of an atom. And the weak interaction keeps atoms together, and it's through changes in it, you get radioactive decay. But these are fields that are incredibly localized, but nevertheless organize the nucleus of every atom. And then, so you've got very localized fields there, which are still top-down because they, the strong interaction keeps the quarks together in a proton or a neutron, and without this strong interaction, they'd fly apart. And when you put them into a particle accelerator and with enormous energy, you can break up this strong interaction, then you can get these separated particles briefly, and then they assemble again. So all of these fields seem to me to have this top-down quality. And I think one of the problems in philosophy of science, and indeed in the thinking of scientists, just in practical working in science, is exactly that this kind of causation is, they've tried to sort of shoehorn this into a mechanistic model. And I've just been reading a book on history of theories of fields in the ether, history of fields in the 19th century. When Faraday thought that the whole of space was permeated by forces and matter was produced by forces that were non-localized, they came together in kind of knots in atoms and things, but they spread through all space. And then Maxwell tried to think of the electromagnetic ether, the luminiferous ether. And a lot of 19th century physicists liked the idea of ether as subtle matter, and to explain its properties mechanically. Maxwell's model was of vortices of fluid whizzing around in tubes for the lines of force. But then what relativity theory in Einstein in 1905 showed that you don't actually need this mechanical ether. The fields are self-sufficient or self-subsistent. But then what are they? And, as Sir Lawrence Bragg said in a wonderful historic footage from the Royal Institution, talking on magnets, giving demonstrations of magnets, picking things up and so on. He says a magnet is the ultimate explanation. The field of the magnet can't be explained in terms of anything except magnets or electromagnetic fields. And he says, what is a magnet made up of? It's made up of little magnets inside it. And so even in superstring and M theory, which try and explain magnetic fields in terms of other fields, is basically fields all the way down.
Of course, the great resistance. I mean, that's one way of characterizing classical Aristotelian etiology is simply to say that it presumes from the first that nature has a mind-like structure rather than mind being an emergent result of physical forces, that all of nature has a mind, because of course a top-down cause, a formal cause, has to be constrained by a finality. I mean, it has to be determined by that for which it is, right? Mm. Which means that there's a sort of horizontal structure in the sense that there's something like the structure of time, in the sense that there's a past and a future and a present, that's in the way that there is in a thought that intends an end, but it also has to exist in a kind of now at a higher level to be a form. I'm being very vague here, but the point is that if you start talking in that way, if you try to recover that notion of form in its classical acceptation rather than the sort of distorted mechanistic picture of it, which allowed it to be dismissed just on the grounds that it was a defective mechanistic model, then of course you're also I mean, I see what the anxiety would be. You begin invoking a prior mind-like structure to the physical relations you're talking about, that has to be there first, and this little mystery of what direction that might seem to point in for...
Yes. But you see, the prior mind-like structure is actually there in field theory. I mean, the whole universe as a universe, insofar as it's a unity, is held together by the gravitational field.
Right.
And that's part of physics. It's not just some wild speculation. Physics has these top-down explanations. It's not just atomistic. It's a combination of top-down and bottom-up theories, and the fields are what give the top-down. And although they may have crudely misinterpreted Aristotle, the fact is that his theory of stones falling to the earth, in terms of formal and final causes, wasn't just something in the mind. Stones actually do fall to the earth and go splat if they fall into water and things. So something was actually happening.
Yeah.
It wasn't just in the mind. And
well, when I say mind, I don't mean just in the mind. I don't mean something that one has dreamt up that exists only in thought. I mean that the very physical relations that, say, compose a tree as a tree are a set of rational relations that are always already mind-like, as if the tree itself, as a physical object, is a thought.
Yes.
That, and you say science is full of top-down and bottom-up, but of course, the ideological, I wouldn't even say ideological, the religious commitment of someone like, say, the recently departed Daniel Dennett, for instance, is that somehow all those top-down causes can be reduced to the bottom-up causes. And
yes, I mean, what he dismissed as skyhooks, things that come from, gravity is a skyhook.
Yeah, well, that's why I'm enjoying this conversation, because actually, you say it and immediately it seems obvious, but for some reason, apparently, our habits of thought don't point towards the obvious. That's what I always thought, though, about the Aristotelian scheme, is that it is simply a recognition of something that's obviously true about the ways in which you describe a thing or event. If I were to ask you what something is or what happened, of course, I'm asking you immediately a set of interrelated questions that can't be separated from one another without making the question vacuous. What it's made of, what shape it has, but also what makes it happen, how does it begin, and what the full expression of all its potentialities are. That would be its final way of thinking of final causality. Is whatever it is defined by that telos, that full expression of whatever its potentials are as a finite thing or event. All that the Aristotelian etiology says is that this very obvious set of rational relations, which is what your mind tells you need in order to define, to recognize something as a discrete something or event in relationship to a universe of other somethings and events, is really an ontology. That there's no reason, but the whole history of modern thought in the West, at least on these things. I mean, we talk about the mechanistic philosophy, in which on the one hand was trying to separate, say, final and formal causes are just supposititious notions of some sort of extrinsic design, which is not what they were. But it's also, you see it in the Cartesian division between res cogitans and res extensas, if these are ontologically distinct realities, and that the latter can only, as you say, to the degree that it possesses order, it's solely through the will of God. It's not something intrinsic to the very structure, or even the Kantian supposition that there's something so utterly discontinuous between the nonological realm of phenomena and what mind does, that all we know of reality is representation, and the representation is itself only a kind of noetic allegory of a reality that we can't know. Whereas with Aristotle, you're in the realm of common sense, which is, the stone falls, and it always falls. Therefore, there's a finality written into the relationship of stone and earth. What is the nature of that finality? And it's somehow it's obviously primordial. It's not something that arises out of the accidental juxtaposition of stoneness and earth.
Well, exactly.
Yeah.
But that's exactly why, you see, I think we can recover something of that sense through thinking about fields in a new way. I think the answer is hiding in plain sight. That the gravitational model, I mean, back to Dennett and skyhooks, I mean, you say, what's an explanation of the tides going up and down in the ocean every day? Well, the gravitational force of the moon. Well, that sounds like a skyhook to me. It's pulling the tide.
Quite literally, yeah.
Literally. I mean, it's so. The thing is that the
but it's amazing, actually, people like Dennett, how many quanta ignota they were willing, he was willing, or they are willing to tolerate, as simply on promissory notes that at some point these will be reduced to blind mechanical interactive forces that are nothing but the exchange of energy between physical mass.
But what's so extraordinary about it is that it's such an old-fashioned agenda, because it was superseded in physics itself by field theories from Faraday onwards.
Well, maybe from Newton onwards.
Well, from Newton onwards, because, well, Newton didn't call it a field theory, but nevertheless, Newtonian gravitation never fitted into this mechanistic model. And in 18th century, 17th, 18th century science, electricity and magnetism were more or less excluded. No one really understood them. It was really only field theory that came to the rescue with Faraday. But if you look at the early magnetic theory of Gilbert, 1600 De Magnete, where Gilbert shows that the lodestone points towards the Earth's North Pole, not the North Pole star, that the Earth itself is a magnet. Gilbert called it the soul of the Earth. And so he's lauded as the origin of modern magnetic theory, but his explanation of the motive power, as it were, of the magnet was the soul of the Earth. It was a formal cause.
Right. Well, of course, psyche literally is a form in Aristotle, the form of the body, but also the form of the living thing. But no, you see, I think, but Mike, that's why I brought up this issue of this etiology being mind-like relations, is I think that's not, that shouldn't be treated simply as a metaphor or as a quaint, sentimental or picturesque way of talking. That actually, there might be some good, hard empirical reasons for calling it the soul of the Earth, that it has an actual rational structure toward an end.
Well, I think that actually what's happened is that the old idea of souls as organizing principles and things has actually in modern science been replaced by fields. Because, the first Greek pre-Socratic philosopher Thales says, the lodestone has a soul. The Greeks thought magnetism was explained by souls, not just living organisms, magnetism. So did Gilbert at the beginning of the 17th century. Then Faraday calls it a magnetic field. And they thought that the soul of the universe held everything together, the anima mundi, or whatever they called it. But then we have the gravitational field. What Aristotle called the vegetative soul shaping bodies is, in my way of understanding, the morphogenetic field. So there's a sense in which souls have replaced fields in modern science. Having been driven out in the 17th century, they came back in the 19th century in disguise under the name of fields.
Well, and also because, of course, the language of soul had been subsumed into the Cartesian picture, in which the soul isn't actually a formative principle. It's not even part of natural philosophy. So, yes, no, I like this. Again, as I say, though, what I find rather shocking is it all seems obvious now that you say it. But honestly, it had never occurred to me before that you could actually... I mean, I've always... that there's a principle of order in the formation of everything, the formation of life, and in the way in which all things consist, that obviously can't be reduced to mechanical causes. But I actually hadn't thought in terms of this of something that's resonant in modern physics as a real
Yes.
quantified in modern physics
Yes.
is actually qualifying for the descriptions.
It's right there, staring us in the face.
Yeah.
I mean, it took me a very long. I mean, it's only in the last few months I've been thinking about this. I think we could continue this later. We have to break off at this stage because it's dinner time. Thanks very much.